is PIM and where does it come from? In an ideal infrastructure, signals are input on one side and output on the other side in the same form, but with a lower level because of the attenuation of the coax cables and components. We are talking now about a non-ideal infrastructure. If there are any connectivity issues at all on the RF line, we talk in terms of a non-linear infrastructure. This could be a loose connector, a bad connection to the cable, dirt or metal parts in the connectors, or even cracked solderings on jumpers or antennas. If there is a connectivity issue and RF signals are input on the coax cables, new signals will be created by this non-linear infrastructure. This is called PIM, passive intermodulation. Additional signals are not good for the system, as they create interference and additional noise. In an ideal infrastructure, the current flow of the RF signal is symmetrical. A symmetrical current flow is a homogeneous current flow between contact points. For example, 360 degrees on coax cables and RF connectors. It is for this reason that we talk in terms of a linear transmission system. If there is dirt on a connector interface, there is no longer 360 degree contact. This results in a non-symmetrical current flow which causes PIM, because the current has some hot spots. In this case, we talk about a non-linear transmission system. Another example is at the assembling of a feeder connector. If the cable is not prepared in the correct way, and parts of the dielectric are clamped between the cable's outer contact and the connector's outer contact, this will result in PIM too. In terms of PIM, there are two main areas where problems can occur. PIM can be generated from within the transmission line, coax installation. This is called internal PIM. The other area is PIM created by external factors. Internal PIM is mainly caused by bad connector preparation and installation, not enough cleaning during the assembly and installation process, corrosion, and bad soldering. External PIM is created by metallic components which are in the antenna's radiation field. These could be rusty roofs, metal chains, railings, etc. Internal PIM must be dealt with by the installation team. External PIM is a topic that has to be discussed with the customer. Any connected transmission line components, such as connectors, cables, jumpers, combiners, TMAs, antennas, etc., are a potential source of PIM. What is most important is that the installation carried out by an installation team is ultimately a low PIM installation which ensures high network quality. As mentioned before, non-linear behavior of the components used in a transmission system creates additional frequencies on the transmission system which nobody would like to have. These products, which we call PIM, show up in several orders. IM3 is the most critical one. As base station systems are getting more and more sensitive on the receiver side, IM5 and IM7 can also be problematic. If there is no IM3, then there will be no IM5 or IM7 either. But why is all this discussion so important to the wireless industry? We already mentioned that PIM is a source of interference for mobile base station system installations. The base station sends out high power signals to users' mobile devices, for example 2 times 20 watts per carrier. Users' mobile devices also send information back to the base station. However, these signals are very low. Therefore, the base station needs to be able to receive and understand low power signals. You can compare this situation with a conversation between two people. If there is no ambient noise, the two people can talk normally to one another. If loud noise starts near to where these two people are located, they will have difficulty continuing to communicate. The power that a mobile device can send out to the base station is limited. Therefore, if noise is created in a transmission line because of PIM, the BTS can no longer understand the mobile devices so well. It can happen that the contact is interrupted or even gets lost completely. You will recognize this in bad coverage, bad connectivity, and slow or no data transmission. In this example, PIM is based on just 2 TX frequencies. A carrier always uses several frequencies. It is the frequency band that enables carriers to offer different mobile services to their customers. Because of that, PIM can block main parts of the RX band, where the BTS is listening to the mobile devices. The result is that the base station can no longer operate at 100%. Things get more critical if each carrier has several frequencies and services on one site location. Also, because of site sharing, different mobile network operators can be located on one site. If the PIM level is very bad, the 5th order of PIM will occur, blocking the RX channel of the BTS2. All this will cause more dropped calls, low data speed, and reduced coverage. If PIM problems are significant, the base stations can even shut down completely. This is the big problem that explains why so much attention now has to be put on low PIM installations. Therefore, only a low PIM infrastructure will avoid these problems and stop the operator from having to offer financial reductions because customers are not happy about mobile services. PIM can come from any connection point in an RF transmission line. If you have a transmission line with PIM problems, you have to find the problem, and the quicker and faster you can solve the problem, the better. With the Rosenberger Site Analyzer PIM Alpha, PIM can be detected on all different positions with a precision of less than 0.3 meter accuracy. Problems can be found very quickly, resulting in short service downtime. A summary of PIM. PIM in a wireless network can cause considerable interference and significantly degrade network quality. PIM is having a serious impact on KPI figures and ultimately results in low return on a mobile network operator's investment because PIM reduces the performance of a site. PIM is site-specific. Consequences: unhappy customers, restricted user experience, inefficient utilization of cell, loss of profit. A low PIM installation requires time and, above all, care. What is most important is that a low PIM installation can only be achieved if cable preparation is chip-free, assembly is neat with repeated cleaning, and the correct torque is set when installing mating connectors. You will now see a video demonstrating how a low PIM installation for a 1/2 inch and 7/8 inch cable should be carried out. The values quoted in the installation instructions, which must be complied with, are shown in the video. In general, only use a chip-free tool. Here you will need a cable cutter for clean cuts, the uni prep tool and pliers, a cable stripper, a gauge to mark the inner conductor, and cable shears. A plastic brush, a cleaning tool with alcohol, a brush and cotton swabs, and a duster that cleans with compressed air. Never use a saw to cut the cable. Move the cable cutter in a side-to-side motion and apply pressure to obtain a clean, smooth cut. Then straighten the cable to about 20 centimeters. Using the peeling tool on the Uniprep tool, peel off the sheath by working your way forward with a light feeding motion and turning the tool around the cable until you can see the end of the outer conductor protruding slightly. Clean off any removed sheath residues. Do not apply any pressure. Use the tool's spring force to apply the tool and rotate it all the way around the cable. Only hold the tool at the bottom end. Only turn the tool until you have cut through the outer conductor. If this is the case, use pressure to cut around the cable again 2 to 3 times to achieve the sheath cut that is required for the right connector assembly. Using the peel insert on the Uniprep tool, peel the cable sheath back to the previously formed sheath cut by turning it around the cable and then remove any residues. Using the pliers, pull and twist slightly at the same time to detach the outer conductor from the inner conductor. If there are any dielectric or plastic residues, use the cable stripper to remove them without scratching the conductor. In order to shorten the inner conductor to the correct length, use the gauge to then mark the length specified in the assembly instructions with a knife. Use the cable shears to obtain a clean round cut at the mark without deforming the inner conductor. Use the marked tool integrated into the Uniprep tool to chamfer the inner conductor. Work with side-to-side motions and turn the tool once, since it only has a cutting edge at 180 degrees. Remove the dirt on the inner conductor with the brush. Unscrew the connector. Make sure that you do not lose any parts. If necessary, slightly loosen the back of the connector so that the seal does not block the threading process. First, thread the back of the connector onto the cable and, if necessary, twist it slightly to prevent the seal from blocking. Push the back of the connector as far as it will go against the cable sheath. Then thread the slotted spring ring into the first trough of the cable. Use the marked device on the Uniprep tool to flange the outer cable conductor. In order to obtain a good base for the flanging tool, create a free space between the dielectric and copper outer conductor beforehand. Widen the entire copper outer conductor. It is essential that there are no dielectric residues on the widened copper outer conductor for a low PIM connector assembly. Remove any residues if necessary and take care not to scratch the conductor. Thorough cleaning is essential to enable PIM-free contact. Clean the contact surface and the inner conductor with a brush dipped in alcohol. Then use compressed air to clean small dirt particles from both the contact surface and the connector, and then dry them. To assemble the connector, attach the upper part and screw in the back of the connector by hand. Then use the pliers to tighten the connector. It is important that the front part of the connector remains still. Repeat the same process with the seal. Screw in the seal by hand and then tighten it with the pliers. Hold the front part of the connector with pliers to prevent it from moving. In general, only use a chip-free tool. Here, you will need a cable cutter, the Uni-Prep tool to prepare the cable for the connector, and pliers to tighten the connector. A plastic brush, a cleaning tool with alcohol, a brush and cotton swabs, and a duster that cleans with compressed air. Never use a saw to cut the cable. Move the cable cutter in a side-to-side motion and apply pressure to obtain a clean, smooth cut. Then straighten the cable to about 20 centimeters. Using the peeling tool on the Uni-Prep tool, peel off the sheath by working your way forward with a light feeding motion and turning the tool around the cable until you can see the end of the outer conductor protruding slightly. Clean off any removed sheath residues. Do not apply any pressure. Use the tool's spring force to apply the tool and rotate it all the way around the cable. Only hold the tool at the bottom end. Only turn the tool until you have cut through the outer conductor. From now on, hold the tool at the front end and apply light pressure until you have completely cut through the inner conductor. If this is the case, use pressure to cut around the cable again 2 to 3 times to achieve the sheath cut that is required for the right connector assembly. Using the peel insert on the Uni-Prep tool, peel the cable sheath back to the previously formed sheath cut by turning it around the cable and then remove any residues. Unscrew the connector. Make sure that you do not lose any parts. If necessary, slightly loosen the back of the connector so that the seal does not block the threading process. First, thread the back of the connector onto the cable, and if necessary, twist it slightly to prevent the seal from blocking. Push the back of the connector as far as it will go against the cable sheath. Then thread the slotted spring ring into the first trough of the cable. Use the marked device on the Uni-Prep tool to flange the outer cable conductor. In order to obtain a good base for the flanging tool, create a free space between the dielectric and copper outer conductor beforehand. Widen the entire copper outer conductor. It is essential that there are no dielectric residues on the widened copper outer conductor for a low PIM connector assembly. Remove any residues if necessary and take care not to scratch the conductor. Thorough cleaning is essential to enable PIM-free contact. Brush the contact surfaces with the plastic brush, then dip the brush in alcohol and clean the contact surfaces again. The alcohol-soaked cotton swabs are designed to remove dirt from the inner conductor so that the interior of the connector's contact point is free from grease and oils. Dry both the contact surfaces and the connector with compressed air. To prevent dirt or metal particles located on the cable from falling back into the connector when you move the cable, seal the inner conductor with a rubber plug. Insert the plug and push it backwards about 2 to 3 centimeters. Then carry out a final cleaning process with compressed air. To assemble the connector, attach the upper part and screw in the back of the connector by hand. Then use the pliers to tighten the connector. It is important that the head of the connector remains still. Repeat the same process with the seal, which must also be tightened with the pliers. Using a passive intermodulation analyzer, measure the values and test whether the cable can also withstand impacts and movements and produce correct and stable measurement results. PIM testing on a site should always start with the spectrum analyzer. As the system ultimately installed includes an antenna, we are testing in what is known as an open system. Different signals can be received by the antenna. If the spectrum analyzer shows no noise in the RX band, a PIM test can be started. If the spectrum analyzer shows interfering noise, the antenna should be disconnected and the transmission line terminated with a low PIM load. Stressed PIM testing, or testing with CW power, should be carried out. It is only with CW power testing that the transmission line is loaded in the same way as the BTS will be during subsequent operation. Only stressed PIM testing ensures high quality and reliable installations. Using the peeling tool on your Uni-Prep tool, peel the sheath at the required location on the cable by running it once around the cable and then apply a slight forward feeding motion. Continue until you can see the outer conductor protruding slightly and you have peeled the sheath for a length of around 24 to 28 millimeters. First, place the contact elements of the grounding kit on the stripped cable, making sure that the cable is lying exactly in the middle of the contact surface. Try to push the two grounding kit circuit boards together as far as possible and turn the screws. Then push together tightly until the circuit boards are completely closed and you are able to tighten the screws by hand. Now, screw the screws into the thread with the Allen key. In its final state, the rubber component must completely enclose the cable. All Rosenberger feeder connectors are designed in the same way. Therefore, the assembly procedure is the same for 4.3 to 10 connectors, 7/16 connectors, and N connectors. Based on this design, Rosenberger feeder connectors are compatible with all common feeder brands. The assembly procedure for smaller cables than 1/2 inch flex is the same as the procedure shown for the 1/2 inch connector installation. It is the same for connectors and cables bigger than 7/8. The assembly procedure is the same for 1 1/4 inch and 1/5/8 cables and connectors as shown for the 7/8 cable and connectors. To get a reliable low PIM site installation, it is highly recommended to use the correct accessories. As installations cannot always be finished in one day, open cable and connector ends as well as unused ports on BTS and antennas have to be protected in the correct way. Rosenberger offers a variety of protection caps to ensure reliable IP67 protection of open or unused ports on a site. This avoids water ingress or corrosion. Low PIM connector installation means keep everything clean, clean, and once more clean. Rosenberger offers all needed components, accessories, and tooling. For any more questions and further information, please contact Rosenberger Site Solutions.